So yesterday in class we focused on the first property of simplifying radicals was that your radicand doesn't have any perfect square factors other than 1. Today we're going to focus on the second one, which was you don't have a radical in the denominator. And this is what we called rationalizing the denominator. So suppose the denominator of a fraction has the form square root of b, or a plus the square root of b, or a minus the square root of b, where a and b are rational numbers. The table shows you how to eliminate the radical from the denominator. This is called rationalizing the denominator. And if you, after watching these two examples, need some more examples, I would go to Khan Academy and type in this phrase, and it will bring up some other videos and other examples for you. So let's focus on the two types of problems. If you look over here at the chart, it says if your denominator is in the form just the square root of a number, you are to multiply the numerator and denominator by that radical. So if you look at example A, right now we have the square root of 5 over 2. I would start by rewriting that as the square root of 5 divided by the square root of 2. Now neither of those have any perfect square factors, so as it is, they won't simplify anymore. However, the problem is that we are not supposed to leave the square root of 2 in the denominator. And so what this chart is telling me is to rationalize or to get rid of that root in the denominator, I am going to multiply the top and bottom, or the numerator and denominator, by the square root of 2. And remember, when you multiply fractions, we just multiply straight across. This will go to the square root of 10 over, well, the square root of 2 times the square root of 2 is the square root of 4. And so our final answer will be the square root of 10 over 2. You should check your numerator to make sure that your radicand doesn't have any perfect square factors. 10 does not, and so this is your final answer. If you look at the other two rows on the chart, this is when you have an expression in the denominator. If it's in the form a plus the square root of b or a minus the square root of b, what we're going to do is we are going to multiply the numerator and denominator by what we call a conjugate. Conjugates, if you look at them, they only differ in sign. For example, if your expression is a plus the square root of b, your conjugate is a minus the square root of b, and vice versa. So if you look at example B, this one has the expression 7 plus the square root of 2 in the denominator. So I am going to multiply the top and bottom by the conjugate, which is 7 minus the square root of 2. And if you notice, it says their product is always a rational number. It may help you, since we have an expression, to put these in parentheses so you can really see that in the numerator we are going to distribute, and in the denominator, you are distributing twice, or what some of you call the FOIL method. So in the numerator, when I distribute, I will end up with 21 minus 3 times the square root of 2. In the denominator, I will have 49 minus 7 square root of 2 plus 7 square root of 2. And then the square root of 2 times negative square root of 2 gives you minus the square root of 4. Now, let's just simplify that denominator a little bit more. There is nothing I can do to the numerator. 21 and 3 square root of 2 are not like terms, so I cannot put those together. And so that will stay 21 minus 3 square root of 2. And there is no other simplifying I can do to that. In the denominator, I have 49. Negative 7 square root of 2 and positive 7 square root of 2 are opposites, they will go to 0. Minus the square root of 4 is 2. And then the last thing I can do is I can simplify my denominator. Instead of writing 49 minus 2, I will just write that as 47. And this is your final simplified answer.